Hey everyone, this is Ritik Banerjee. I'm going to show you my prototype project about cooling liquids. It can be used for cooling ethanol, water, or anything, and it's very functional for the chemistry lab, physics lab, and also mainly biology lab also, because chilled ethanol is used during DNA isolation. So for that I made some things. I will show you one by one. At first I will start with a pump. This is a submersible pump which has one inlet. Inlet is directly the body. It takes the water from the hose here, and also it pumps out the water through this pipe, and this pipes goes to the next thing. This block, this is also known as water block or water cooling block, or anything you can say. The main function of it is to circulate the water. The water coming through this pump will get circulated in a zigzag pattern inside, and it will come out and again go back to the water. It contains water. This bucket or anything you can call it, it contains water. And the main thing, the power supply, that's a huge thing. If you can see the power cables here, I'm bringing it forward. Here's AC power line. This is a 5-volt adapter for powering this small pump, and this is this is the power cord for the big adapter. It's 12 volt 10 amps. It's dangerous to work with it, and it have all its connection in this side. I will not tell you the connections and complicate the video. And after that, so the next thing, what is this big thing with grills and all and a fan below it? Actually it's a heat sink, and in between I used a Peltier module or Peltier device. So its number is TEC12106. You don't need to care about the number, just the function of the Peltier module. These two wires come out of the Peltier module. Actually, when we give the voltage to Peltier module, one side of the Peltier module gets extremely cold and the other side becomes extremely hot also. The main function of Peltier module is create a temperature difference. It does not know it's cooling or heating. It knows that I have to create a temperature difference between the two plates. It contains semiconductors that helps in doing that. I will not get very much into it, and this will complicate the video and I don't want it. So anyway, the hot side is placed with this big heat sink. This is called heat sink. It's nothing, just a grill of aluminium. What it does is takes the heat from that hot side of the Peltier module when we power it on, and it releases the heat in the all the directions in its grills. And also this fan, this is a small fan, 12 volt DC fan. It's also used in computer. It cools down this module. The idea is, if we cool the hot side down, then the temperature of the upper side of the Peltier, which gets cold, will get more colder, because the Peltier will create that difference. If it's getting hot up to 50 degrees, and if we take an example that the Peltier is doing a 20 degree gap, then the upper side temperature will be 30 degree. But if we can cool it down to nearly 30, that's not very practical. Yeah, we can say up to 40 at least. Then we will get at least 20 degree temperature, and it can go very less, because 20 degree is not the actual optimum gap. This Peltier module at 12 volts, and it takes 3 to 4 amps or maximum 6 amps at very high power when it's completely functioning. It will only it will have a difference of about 45 to 60 degrees. So if we cool it down to, like, it's getting very hot with this fan, I have to change that module. That's why I am calling it a prototype. It can cool it up to 70 degrees, and here we get 10, 15 to 20 degree, and I am trying to cool it at least up to 40 degree. Then we will get very chilled water, like minus 14 degree C, and it gets chilled. So I have to change this Peltier block also. That's a different thing. Let's come back to the video. I am just deviating. I'm into my own world. Okay, so we will take power supply from this and we'll supply it. What's happening is the cold side is connected to this water block. The water coming in through this hose just runs a zigzag pattern and gains all the cold temperature that is accumulating in this block, and again the pipe goes back to the tub and dumps down the cold water. And what's the function of this then? It will continue doing it for a while. Like this module, after nearly 10 to 15 minutes, it can nearly create a temperature difference between the water we have started with to the water after 30 minutes or 15 to 30 minutes, we will get at least 20 to 30 degree difference in temperature. So now the water in my house is nearly about 35-37 degree, maximum 40 is too much. And now the water here, if we turn it on for nearly half an hour, we will get nearly 20 degree, and below that also I got 11 degrees also. It's quite chill. We can use it to cool anything. So let's start. I'm powering off this whole chunk of metal. Okay, the fan is on. I can feel it, you can't. And also the Peltier is also on, just the pump is off. I will turn on the pump so you can hear the voice. If you can't, let me help you out. See, you can hear the pump is also working, and here you can hear the small fan is also working. It's doing its job of cooling. And okay, you can't feel the temperature, it's getting a little bit hot, and I can feel it, and its plate is also getting hot, and this is getting cool, quite cool. It's nearly 10 degree already, and it's cooling down the water, and it's filling back up again. So yeah, this is my project, and thank you for watching the video till end. It's not very common that everyone watches the whole video. Okay, so thank you everyone.